Carburetors. I hate them. They're all little polished turds with tiny tapered needles and several different jets, all of which will vaguely approximate the amount of fuel that an engine needs in different conditions, but only after hours of tuning and rebuilding. Carbs suck, but fuel-injected engines come from the factory with these little black boxes that say, "No, I'm a secret." You can reprogram them sometimes to get a different tune, but if you really want to get into the meat and potatoes of engine control, you need an aftermarket ECU. And if you want the most capability for the least amount of money, you probably want a Megasquirt. Couple of important notes right off the bat. I'm going to be going over the installation of a Megasquirt on a 4-cylinder motorcycle engine and a MicroSquirt on a single-cylinder motorcycle engine. Some of the information will be specific to modern motorcycle engines, namely the crank and cam sensors and the coils, but most of it's the same for many gasoline piston engines. Also, this video is not sponsored or supported by Megasquirt or any of the sellers like Amp EFI or DIYAutotune.com. I just like the system and I'm using it for reasons that I will talk about right now. If you're anything like me, and let's be honest, you are a little bit, you like to modify your vehicles. New exhaust, new camshaft, but pretty quickly you reach the end of the capabilities of the little black box that controls your fuel injectors. You can take your vehicle to a dyno and have them flash a new tune on the stock ECU, but what if you want to modify it more later? There are piggyback systems that will let you somewhat modify the fuel settings, but their capabilities are limited, and by the time you get all the add-on boxes for upper injectors and auto tune and no lift shift, you're in it for quite a bit of money. Enter the Megasquirt. The Megasquirt replaces your engine control computer entirely, so you can make it do whatever you want. You want to run nitromethane, you want to turbocharge and control two-stage nitrous and add traction control and also have it turn on a little red light Wednesday afternoons at 4 p.m. Done. About 20 years ago, I had an old Dodge Dart that I shoved a big block into, and I was thinking about how much I hated carburetors when I came across the original Megasquirt. Back then, you could buy the board, but you had to go to Mauser and buy 100 different components that you had to solder together yourself. It was pretty rudimentary, but the hardware, software, and capabilities of the system have grown tremendously. Now you can buy whole plug-and-play Megasquirt systems for common engines. You can still also buy a kit and solder it together, but I'd rather buy an assembled one and then disassemble it to see what it looks like inside. Neat. It can do a lot, and it's pretty cheap for its capabilities. That's kind of the advantage. You get a lot of possible uses for not a lot of money. I mean a lot of possible uses. Basically any combination of injectors, sensors, cylinders, rotary engines, traction, launch control, self-tuning, nitrous, turbo. You could probably legitimately run a jet engine on this ECU. This advantage is also its main drawback. The system is so capable and adaptable that there are seemingly billions of different settings, and not all of them are very clear on what they actually do. There are a lot of people who like to geek out on things a little too much, and there are lots of areas where these people thrive. Unfortunately, this makes these areas more difficult for those of us who don't spend our Saturday evenings analyzing the subtleties of MOSFET design or whatever. If you just kind of want a system that works, it's kind of maddening. You have to dig deeper than you want to or have time for. I don't usually love this sort of stuff, and the Megasquirt is kind of the same way. You might also hate this sort of unnecessary complexity, what an old boss of mine used to call intellectual masturbation. And if you do, you're in luck, because I'm going to show you exactly how to install a Megasquirt and a MicroSquirt on a motorcycle engine. I'm going to be doing this on my CBR 1000RR, but I've previously MicroSquirted my CBR 250R engine. Neither of these engines are in the motorcycles they came out of. The 250 is in my Grom and the 1000 is in a car. There's more info on these swaps in my other videos, but it doesn't really matter what the engine is in, so try not to worry about that part. There's the Megasquirt, but then there's also the MicroSquirt. There are actually a few different flavors of each going back a couple of decades, but I'm going to be talking about the MS3 Pro, which is going on the 1000, and the MicroSquirt, which is going on the 250. These two ECUs sort of bookend the Megasquirt spectrum. The MS3 Pro has all the bells and all the whistles, most of which I'm not using. The MicroSquirt has fewer capabilities, but it's still perfectly adequate for most motorcycle installs. Here's the difference. The MicroSquirt lacks full sequential injection. It will inject the correct amount of fuel during an engine revolution, but it won't necessarily inject right when the intake valve is open. It might spray it on the back of the closed valve. This is actually not that bad. It makes for a little bit of a more rough idle, and it's not the best fuel mileage at low RPMs, but at high RPMs, which motorcycles are at most of the time anyway, the injector sprays for longer than the valve is open. So your benefit from full sequential injection is limited. The Micro also has fewer outputs and inputs. The Mega has lots of extra wires to hook up things like wheel speed sensors for traction control, nitrous, rev limiter, no lift shifting, stuff like that. So plan out your build and see what you need. If you don't need the extra outputs or inputs, you can save a decent chunk of money by buying the Micro. It's also a lot smaller. A couple of other limitations: the Micro has no control over a stepper idle air control valve, and it doesn't have an internal map sensor. The map sensor is not really a big deal. You can use any external map sensor. As for the idle control, you can buy an external box to control your stepper IAC. You can also just use an on-off solenoid to get a little more air in during warm-up. It's crude, but it works fine. It's hard to say exactly everything you need because all the setups are going to be different, but there are some things you will for sure need in any installation. You will, of course, need a Megasquirt and a wiring harness. You'll also be doing a lot of wiring, so you'll need a crimping tool, crimp connectors, heat shrink, and some kind of abrasion cover for your wires, zip ties too. If you haven't watched my video on how to rewire your car, that'll probably be helpful. The link is in the description. If you're running the Micro, you might also need an external map sensor. Get this one. You might also want to buy an adapter to control your idle air control valve. You can get this at EFI Source. More on this later. You probably also need igniters because the ones on your bike might be built into the ECU. You can get around this with different coils or with a quad spark. Again, we'll talk about both of these in detail later. You'll also need some time and some patience. This is not a plug and play and go do wheelies in one afternoon. It will take at least 2 afternoons. At least. You should start by reading the manual. It's about 300 pages long, but you only need to read about 7 pages. I'm just kidding, you have to read the whole thing. Most of it, anyway. There is a lot of functionality in these controllers, and you should have a decent understanding of the wiring and tuning. Make a pot of tea and block off a couple of hours to go through it. There are a lot of pictures, so that's nice. Make sure you get the correct manual. There have been several different variations of Megasquirt and different sizes and functions and different software. And there are also different updates to the individual manuals for each ECU. It's kind of confusing. Just make sure you have the most up-to-date manual for your specific Megasquirt. If you read the manual and you still have questions, the forums or Facebook groups are usually pretty good at giving quick and accurate responses. But if you ask a question that's already answered in the manual, someone will probably tell you to read the manual, and he will probably be kind of a dick about it. These places have a slightly higher concentration of condescension and pedantry, but they're also pretty helpful, so... You can get a wiring harness for your Megasquirt, and I did. You can also just buy the connector and crimp the wires yourself. I recommend getting the harness. It has the correct type of automotive wire, and they're all labeled all the way down. You don't need all the wires. I used about half of them on the MS3 Pro and all but about 6 on the Micro. I took out all the wires I didn't need. This is way better than cutting them short or looping them up in the engine bay. To do this, you need a tool, and I don't know which one. I tried this one to push the pins away, and that didn't work. And then I tried this thing in the front and the back. It sort of works in the front if you take the red cover off. Anyway, I just used a small screwdriver. Once you have all your unneeded wires out, you can go ahead and plug the holes that no longer have wires. Get this part number. Buy 50 of them or so. They're 16 cents each. Put them in fat end first in all the open holes. The MicroSquirt comes with a pinout conveniently written on the back of the case. If your Megasquirt comes with one of these wiring cards, keep it handy and take notes on it. A lot of the labels aren't super specific or helpful, like my fan isn't labeled fan, it's PWM out 3. Some of this stuff is confusing. Digital frequency in 3 unconditioned, IAC1B, I don't know what that is. Actually, that's probably for the idle air control valve, so maybe write idle air control valve next to those. For the actual wiring, you have 2 choices. You can remove the whole wiring harness and then rewire the whole bike, or you can just leave the old harness in and rewire just the sensors, injectors, and coils. I left the harness in the single-cylinder bike, but I rewired the 1000, mostly because the engine's in a car. If you're looking for an easy path, just leave the old harness in. Although, if you're doing this on a motorcycle, rewiring may not be as hard as it sounds. You might have sub-harnesses in the front and rear that you can leave in and tap into. Interesting thing about Honda motorcycle coils, they don't contain igniters. They're just coils. The igniters are in the ECU that we just threw in the trash. The Megasquirt also doesn't contain igniters, neither does the MicroSquirt, but you do need them. There are 2 easy solutions to this. One I did on the 250 and one I did on the 1000. The 250 is a single, so I just bought a new coil that had an igniter built in. This is from a GM LS2 engine. These are great. They're super common to use with the Megasquirt, so the settings are all easy and they have the igniters built in. Just run your Megasquirt wires to it and also 12-volt and ground wires. Then fab up a spark plug wire by buying some sort of DIY plug wire kit and hacking it together. Then connect it to the spark plug. The other solution is to buy what's called a quad spark. DIYAutotune.com sells this for $94. I'm using it on the 1000. It has igniters inside, so it just goes between your Megasquirt and your motorcycle coils. Super easy. There are two main types of fuel injectors. There's peak and hold, also called low impedance, and there's saturated, also called high impedance. You need to know what kind of injectors you have. Depending on which Megasquirt you have, you might only be able to drive high impedance. Most modern injectors are high impedance. You can tell by measuring the resistance across the injector terminals. Low impedance injectors will have a resistance between about 1.5 and 4 ohms. High impedance injectors will have a resistance between 8 and 16 ohms. The Hondas are just under 12, so they're high impedance. Yours are probably also high impedance. It used to be that the big aftermarket hot rod injectors were all low impedance because they could flow more, but these days even high performance stuff is often high impedance. A lot of modern sport bikes have staged injection where each cylinder has 2 injectors. One is right near the intake valve and one is farther up in the intake manifold. As the engine spins faster, the upper injectors start to inject some of the fuel. This allows the engine to atomize the fuel efficiency at high RPMs while still having good low-end power and idle. Megasquirt can run these injectors, and setup is super easy. Just wire your low injectors to the A, B, C, and D injector wires. The upper injectors get wired to the E, F, G, and H wires. Here's an important note about wiring your injectors and coils to the Megasquirt. Your engine has cylinders and they each have a number. Inline bikes usually start counting from the left, 1, 2, 3, 4. The Megasquirt has outputs for injectors and coils that are labeled A, B, C, D. You might think that A goes to cylinder 1, and B goes to cylinder 2, C to 3, and D to 4, but you would be wrong. The Megasquirt always fires A, then B, then C, then D. So if your firing order is 1, 2, 4, 3, like mine, the A goes to 1, B goes to 2, then C goes to 4 because that's the next one to fire, and D goes to 3. There is a setting in the software that asks you for your firing order, but that's for the trim tables if you have cylinder-specific trims. It has nothing to do with the actual firing order of the wires coming out. So find out your wiring order and wire up A, B, C, D to the cylinders in the order that they will fire in. This was really easy on the 250 single. Don't forget all the ground wires. There are 6, I think, on the MS3 Pro. Run them directly to the battery. Other Megasquirts might have a different number, but they all have multiple ground wires as far as I know. If you have issues getting weird readings from your sensors, you might have forgotten a ground wire, or you might have a bad ground connection. If you get an MS3 Pro, some of the sensor wires come already shielded on the harness. This shielding is connected together at the plug, and they go to one of the ground pins. You don't need to ground this shielding. In fact, make sure you don't. The sensor side of the shielding should not be connected to anything. It should just end. If you connect it to the body or the engine or any ground, then that shielding becomes a ground path and it stops shielding. This was a little confusing for me because the manual says that the pin must be connected to ground. Do not leave this ground disconnected. Well, on the Megasquirt, there are 2 ground wires on the white plug. One of them needs to be grounded to the battery, and the other one is used as wire shielding. After I had mine all wired, I had my timing signals bouncing around so much that I couldn't get it to start. It would crank fine, but then as soon as it started to fire, the timing would just fly around and the engine would die. I dug around online for a while, asking questions, reading forum posts, trying to figure out what was up, and I didn't get anywhere, so I just double-checked all my wiring. Turns out one of my ground wasn't hooked up. I did read the manual, and I was tripped up when it said that pin 13 was connected to the shielding and pin 16 was supposed to be grounded. Well, my pin 16 was connected to the shielding, and you're not supposed to ground the shield, so I just moved on. Well, apparently one of these 2 needs to be grounded, and the other one goes to the shielding. Anyway, my harness didn't jive with the manual. I don't know if they changed the harness and didn't change the manual, or if they just assumed that I would be smart enough to figure it out. Either way, if you have an MS3 Pro, make sure you have one of these 2 wires on the white connector going directly to the negative battery terminal. Now would be a good time to clean up your mess so you can actually find your tools. Go ahead, I'll wait. As I said, the Micro doesn't have control for an IAC valve, but you can buy an add-on that will allow the Micro to control a 4 or 6 wire valve. To wire it up, you need to know which wires are connected together through the coils. To do this, you just check the resistance between the wires. There will be some resistance between 2 connected wires and infinite resistance between 2 not connected wires. Once you know which wires are connected, wire up 1A and 1B to one coil and 2A and 2B to the other. Yes, those are the wires that I thought were useless earlier. Too quick to judge. If you have a 6-wire valve, you have to figure out which 2 are in the middle and then ignore those 2. And if you have a 5-wire, you actually have to open it up and disconnect the wire that's connected to both sides and then wire it as a 4-wire. This might not be possible without destroying your valve. If you have a 2-wire idle air control valve, then it's either an on-off or a PWM. For this, you just wire it into one of the high current outputs or the PWM outputs and then tell Megasquirt to activate it at some coolant temp below 130 or something like that. The MicroSquirt can handle the 2-wire type valve. The Megasquirt can drive a solid-state relay using a PWM output, so you can get a variable speed fan control. If you're doing this, you'll need a solid-state relay. Just get standard Motor Products RY330K. The wiring looks like this. This is nice, but not entirely necessary. You can just run an output to a relay for on-off fan control at a certain temperature. The MicroSquirt does this with the WLED or ALED outputs. Connect these to the relay that powers the fan. I just use on-off to control my fan. It comes on at something like 205 degrees and goes off at like 185. For that, you can just use a regular relay. So that's all the outputs. The next step is to wire up all the inputs. The ECU needs the inputs so it knows when and how much to output. We have the basic environmental inputs like temperature sensors, manifold pressure sensors, throttle position sensors. These are all pretty easy. We also have the trigger sensors for the camshaft and crankshaft. These are a little more involved, but pretty common among motorcycles. We'll start with the easy ones. You can use the temperature sensor that comes with the motorcycle, but you need to know the resistance curve. It's pretty easy to find out. The sensor will have 2 pins and the resistance across them will change as the temperature changes. The ECU reads this resistance and knows the temperature. You just have to tell the Megasquirt what resistance means what temperature. Honda uses a 3-wire coolant temperature sensor, but the Megasquirt uses a 2-wire. This seems odd, especially considering the sensor looks almost exactly like the GM sensor commonly used on Megasquirt. Well, it turns out that the Honda 3-wire is actually 2 2-wire sensors. So 2 of the wires are wired like you see in the Megasquirt wiring diagram. The 3rd wire is actually just connected through the sensor to the engine ground. This single wire goes to the dash, and this is pretty awesome for us because we can have the ECU reading the temperature on the 2 wires, and we can also keep our dash temperature functioning correctly. You can also just add a GM 2-wire sensor in the system. I did this on the 250. I added it to the radiator. This is actually a bad idea because you can't get a good temperature reading during warm-up. The thermostat's closed, so while the engine temperature is creeping up to 120, 130, 140, the sensor still thinks it's 70 degrees. For some reason, I didn't think this would be a big deal. Maybe I was planning on taking the thermostat out. I don't remember. Either way, it seems pretty short-sighted in retrospect. I got rid of that sensor, and then I just used the one that came with the bike. Like I said, if you want to do this, you have to know the sensor's resistance curve. You have to tell the Megasquirt that this resistance equals this temperature. You might be able to Google around and find the sensor curve, but if not, you need to take the sensor out and put it in a hot water bath. Heat up some water with a thermometer and just write down the resistance at 3 different temperatures. It's good to have a wide range. Pick something near 200 and something near 60. That way you have your starting temperature and your running temperature. Then pick somewhere in the middle. You need 3 because the curve is not linear. Once you have these numbers, plug them into a spreadsheet and graph that shit. I didn't actually have to do this on the 250 because I had that GM sensor in the radiator. I just measured the resistance on both sensors at 3 different temperatures. Since I knew the GM sensor curve, I could calculate the Honda curve, but it's just easier to use the stove. Intake air temperature sensor is the same thing, but use a heat gun or whatever hair dryer is in your bathroom. Throttle position sensor is super easy. It's usually just a potentiometer. You give it a ground and 5 volts and it'll spit out a varying voltage that changes depending on your throttle position. You need to find out which wires to hook up to which inputs on the ECU. Wiring diagram will be helpful here. You have a ground, a power, and a signal. The ground is probably shared with the map sensor and the temperature sensors, so find out which wire has the same color for all of those. That's probably your ground. The power will probably be shared with the map sensor, but not the coolant sensors. The last one is your signal. You'll do the same with the map sensor if you're using the one that came with the bike. This is how most modern fuel-injected motorcycles are wired. It's the same way the Megasquirt's wired, so it's pretty straightforward. Once you know the wires, hook them up to the correct inputs. Like I said, the ground is shared with the throttle position, the temperature sensors, and the map sensor. Comes from pin 18 if you're using the MS3 Pro, and pin 20 on the Micro. So get that wire and crimp 4 wires coming out of it for all those sensors. The 5 volt is shared with the map sensor and the throttle position, so make sure to do a double split off on that one. Double check your diagram for the correct sensor inputs. Throttle position is easily calibrated later in the software, so we don't need to measure anything on it. The Megasquirt comes with a built-in onboard map sensor, but the MicroSquirt doesn't. You don't need a map sensor, you can just tune with throttle position, but I recommend putting in a map in case you want to tune with it later. You'll usually get a better tune. For the Megasquirt, you'll just plumb a tube from your intake to the sensor on the board. For the MicroSquirt, you can buy a GM map sensor and wire that in. The software has the curve for this already built in, so you just select it from the drop-down. I'm going to use the map sensor that came with the bike. To do that, I just need to find out which wires were which, the same way I did with the throttle position. I also need to get the output curve, but instead of heating water, I need to pull a vacuum. This is linear, so you only need 2 points, but get 3 just to make sure. Ambient pressure can be 1. Check your local barometric pressure. You'll need a vacuum pump to get the 2 others. You can buy a cheapo hand pump, but I have this vacuum container for fiberglass resin that I'm going to use. Just pick 2 numbers. Engines usually idle around 5 psi absolute, which is a vacuum of around 20 inches of mercury. One of your points should be somewhere around there. To program this curve into the software, you need to find the values at 0 volts and 5 volts. To determine this, plug your numbers into a spreadsheet, graph it, and see where the line crosses. You can also use the numbers you have to calculate the slope of the line and do the math by hand if you're a nerd. You need a wideband oxygen sensor. Yeah, it's another $200, but it will make tuning your engine infinitely easier. You can tune by the seat of your pants and smelling your exhaust and looking at the spark plug suit if you're really into old-timey things. You can also fix a cavity with a rusty hook, and I assure you both of these things are equally enjoyable. The Megasquirt can run in closed loop using the oxygen sensor to target a specific air-fuel ratio. I use this one, but you can get other ones for a little bit less money if you're on a budget. If you have a distributor or some other ignition control, you can run the Megasquirt just for fuel. In this case, all you need is a tachometer input from your ignition system to tell the ECU what your RPM is. But we're not doing that. We're going to use the Megasquirt to control both fuel and spark. In this case, your ECU needs to know where it's at in its rotation. That way it knows when to spark the spark plugs and when to spray the fuel injectors. There are two different types of sensors that are commonly used to measure engine location. Hall effect sensors, which typically have 3 wires, and variable reluctance or VR sensors, which usually have 2 wires. Both bikes use VR sensors. The 250 only has one on the crankshaft because it's a single cylinder. The 1000 has one on the crank and one on the camshaft. When a sensor is triggered, it creates a voltage wave that looks kind of like this. There's one clean edge and one sort of not so clean edge. If you swap the 2 wires, these edges change. So if the one going up is clear, then when you swap it, the one going down becomes the clear signal and the one going up becomes the not so good one. You can change this in the settings, so it doesn't really matter how you wire it up, but it's good to have them both going up or going down. The trigger wheel is what the crank and cam sensors pick up on. It's a toothed wheel like this, or sometimes built right into the clutch or stator with teeth coming off like this. You need to know how many teeth there are, how many are missing, and where top dead center is in relation to the first tooth. Rotate your engine to top dead center for cylinder number 1 on the compression stroke. After that's done, take off the side cover and look where the trigger wheel is in relation to the sensor. Megasquirt times everything off the number 1 tooth. If you have a missing tooth, like the 250 does, the number 1 tooth is just the first tooth after the missing tooth. So rotate your engine so that the sensor is on the number 1 tooth. Then rotate the engine to top dead center while using a degree wheel. The number of degrees you rotated is your number 1 tooth angle. The manual has lots of pictures that explain this pretty well for several different setups, so if this all sounds confusing, take a look at the trigger wheel section of your manual. Unfortunately, measuring the angle between the trigger wheel and the sensor is difficult on some bikes because the sensor is bolted to the side cover. You can't see where the sensor is in relation to the trigger wheel because to see the sensor you have to take the cover off. Do the best you can to measure where the sensor is in relation to the trigger wheel, specifically the missing tooth if you have one. If you have a cam sensor, you might not have a missing tooth on the crankshaft. I got kind of lucky with the 1000. You can actually tell where the sensor is based on the outside of the casting. The outside has these 2 little mounds that are right where the sensor bolts in. The sensor is right between these little mounds. I took a picture of this and I pulled it into a CAD program where I drew everything out. I set the engine so that the single tooth of the camshaft was right on the camshaft sensor. Then I measured the angle from the crankshaft top dead center mark to the engine case top dead center mark. This is how many degrees before top dead center the engine was at when the camshaft sensor was triggering. If there's not a missing tooth on the crankshaft, then the number 1 tooth is the first tooth on the crankshaft to pass the crank sensor after the camshaft sensor has been triggered. Again, this might be more clear if you look at the manual. I measured where the teeth were in relation to the top dead center mark on the crankshaft and added that to my drawing. Then I could measure how many degrees the crankshaft would need to rotate to trigger the number 1 tooth. Then it was just some simple math to get the number 1 tooth angle. Again, this isn't super clear, so maybe check out the manual. You'll also probably get a better understanding after you start taking your bike apart and looking where the sensors and the teeth are. These sensors turned out to be a huge pain in the ass for me on both engines for 2 different reasons. The problem on the 1000 was the ground that I didn't ground. I already talked about that. The 250 turned out to be a pain for reasons that you probably won't run into. I micro-squirted this engine with the older Micro. It has a metal case and it looks like this. The current Micro comes in a sealed plastic case and it looks like this. You want the new plastic one. The old metal one has a jumper inside that you need to switch if you're using a VR sensor instead of a Hall effect sensor. This was not super clear. Also, the older version uses an older VR sensor conditioner. To get a clean signal, I had to put a sensor in line. This was also hard to find in the mountain of different manuals and versions of manuals. Not a lot of people use the older Micro. I tried a 10K resistor and I got the engine to start, but it would only rev up to a couple thousand RPM. So I put a potentiometer in line and just adjusted it until I could get the engine to start and rev all the way up. Then I measured the resistance and replaced the potentiometer with a resistor. Hopefully you won't have to deal with any of that. If you get a lot of signal noise at high RPM, you can put a 10K resistor between the VR wires. I didn't need to do this. The Megasquirt can handle tons of different styles of triggers, lots of combinations of numbers of teeth and missing teeth. It can also handle uneven spacing of teeth, but one of the few things it can't handle is the setup my 1000 has. It has a 12-tooth wheel on the crankshaft that doesn't have any missing teeth, and on the camshaft it has a 3-tooth wheel that is unevenly spaced. To get this to work with the Megasquirt, you actually have to cut off 2 of the teeth on the camshaft wheel so it just has 1 tooth. It's pretty easy to do, but you do have to take off the valve cover, which might be a pain depending on how your engine is set up in your frame. It was super easy for me. As I said before, the Megasquirt has lots of inputs and outputs, digital, analog, PWM. You can control lots of things with it. The 2 things I'm going to control with it are the nitrous oxide and my secondary launch rev limiter. You'll probably have different things to control, but I'll go over these 2 so you'll have an idea of how to wire things up and how to program them. For the nitrous wiring, we'll have a switch that tells the Megasquirt to activate the nitrous and an output that goes to a relay. I'm using digital switched in 2 for the activation. That switch goes to a ground, so whenever the switch is on, the Megasquirt sees a ground and knows it's time to party. The output goes to a relay, and that relay activates the nitrous solenoids. I actually rewired this after I initially set it up. I put in a double pole switch to activate the nitrous, and I ran the activation back through the second pole. This way, if I forget some setting or program something wrong, I know the nitrous won't be able to turn on unless the switch is on, no matter what the ECU is trying to do. I'm also using launch control based on the clutch. The easy way to do this is to use a clutch on-off switch and wire it into a digital input, but I'm using a clutch pressure sensor. This sensor gives a 0 to 5 volt output based on the pressure in the clutch fluid, so it knows pretty accurately when the clutch is disengaged. To wire this up, I connected the 0 to 5 volt output of the sensor to one of the analog inputs. After everything's wired, you're going to want to turn on the ECU to check that it works. Be aware that it might turn everything on with it, your fan, your fuel pump, and your nitrous solenoids. It did this for me because I hadn't loaded any tune into the ECU. You can pull all the fuses for those things to get your first tune in, but just be aware that it might happen. Next week, I'll go over the programming. There will be a link to that video in the description when it's available, also probably like here. Get that thing wired up and come back for the fun part.